Okay, so we're going to talk about the volume of the cylinder. Alright, so it is very similar to the volume of the prism, alright, which is the base area multiplied by the height. Okay, if you notice the formula is the same. Okay, so what I have here is a circle. Alright, so a circle. Now, so how do I get the cylinder? Okay, same principle. I basically stack up a bunch of circles. Stack out a bunch of circles. Okay, and it basically form a cylinder, right? A 3D figure, a cylinder. So the whole volume of this is basically the area of one circle multiplied by the height that I stack them with, right? And that will give me the volume. So hence the formula is this, very similar to the prism. In fact, easier than the prism. You don't need to care about what is the base area because it will always be a circle. Okay, for what we are learning, okay, the cylinder will always be a circle at the base. So this is how we find the volume of the cylinder. Okay, next we're going to talk about the surface area. But before that, remember, we talked about there are three types of cylinder: the closed, the open, and the pipe. Right, the closed, open, and the pipe. So a closed cylinder you can think about as this one, or a closed container. So if I want to calculate the surface area, I need the area at the side, alright, plus the two circle top and bottom. Right, so this one will be on this will be the closed cylinder. Right, so you can see on the diagram here, the net, there are two circles. Okay, one on top, one below. Right, so for the open cylinder, you can think of it like a cup. Okay, so over here I have my cup. Okay, let me zoom out a little bit. My cup here. So my cup here is a cylinder. So obviously inside there's some water. Okay, so the base, I need, if I calculate the surface area, I need to have the base. If not, my water will flow out, right? But the top, of course, I do not need to cover it. Okay, so that is a open cylinder. So how about a pipe? Okay, so what is a pipe? Looks like a pipe is basically a cylinder whereby you do not need to have two circles. So what I have here is a toilet roll. Right, so I assume all of us visit the toilet, right? So I visit the toilet, right? So whenever we go to the toilet, you can think of the toilet roll is a cylinder. Okay, it is a pipe cylinder. So you see the core is made out of the cardboard. I do not need to include the area of the circle at the top and bottom. Okay, it is see-through, hollow. Okay, so this is that's why on the net you do not see any circle here. Okay, now so how do I find the total surface area? Now the top and bottom, they are both circles, so that one is quite easily understood, right? So now the problem is the curved surface area at the side. So as you can see, the toilet paper, curved surface area is basically the paper at the side. Okay, so if I mark here, I'm gonna start, right? Okay, or rather, I mark here. Meaning, if I unroll my toilet paper one round, all the way until here. Okay, so okay, there's a line here. Right, so what I'm going to have will be a rectangle piece, a rectangle. Okay, just like what you see on the net, a rectangle. Right, so see if I fold it back to my toilet roll, okay, circular. Now my length is actually the circumference, right? If I fold it like that, the length is actually the circumference of the toilet roll. Okay, so my circumference is 2 pi r. Okay, let me zoom in now. So you see over here, my circumference is 2 pi r. 2 times pi times 7. Okay, 7 is the radius. Alright, and what is my breadth? Is basically the height. Okay, toilet roll, the height, the dotted line here, that we tie off to whatever we need. Alright, so here is the 15 cm. Alright, so that's why the curved surface area is 2 pi r h. Okay, circumference multiplied by the height. Okay, take note, do not confuse with the volume. Volume is pi r square h. The curved surface area, the circumference, okay, you may want to write it down, is 2 pi r h. Right, because it's the length times the breadth. Okay, so what are the different types? You see, closed cylinder, the net, I have two circles. That's why in the beginning, I need to add two circles. 2 times pi r square. For the open cylinder, I only have one open end. That means I have one circle. That's why I need to add in the area of one circle, pi r square. The last one, both ends open. There is no circle. Hence, I do not need to add any circle, just the curved surface area. Right, so the ending part here, curved surface area, they are all the same for all the three. So here, this is a 2. Okay, so that's it. Okay, you may proceed on to example 1.